Hello, welcome to my Tech One. In this video I'm testing different nozzle diameters, and what I have here are the plated wear resistant nozzles from the MicroSwiss, and I have them from 0.2 up to 1 mm in diameter. Everything will be printed on my Ender3V2, where I already installed the MicroSwiss direct drive and all-metal hotend, and I will use the same filament, which is in this case the Polymaker's Polyplus PLA. What will I print? I'm not sure yet for the final decision, but probably the Benchy will be the reference, and of course with smaller diameter nozzles you would use them to get more details, and they will be better visible with the smaller benches. The bigger diameter are for speed, but with the less details. Also, 0.24 mm nozzle will be the reference. So everything I print with smaller or bigger nozzles, everything will be printed with 0.4 mm too for a reference. And also I'm quite curious about the clearance. Will I get better clearance or not with smaller diameter, or worse in with bigger nozzles? And another thing I want to test is earlier I did some experiments with the 3D printed bolts, and I noticed, for example, with M6, M8, they are with the 0.4 mm nozzle, I have only maybe one layer which creates the thread. I'm talking about the horizontally printed bolt because they are much stronger. And I'm very curious, if I used a smaller diameter nozzle, maybe I can get two layers to get the shape of the thread, if it will be stronger or not. And I'm not sure with the bigger nozzles, for example with 1 mm, I don't think I can print M8 or something like that, but I will see. And I started with 0.4 mm nozzle, and this is the 50% size Benchy. This means half of the original size. And just for reference, this is the full size Benchy, which I printed earlier. But of course I reprinted it on the Ender3 with this nozzle and with the same filament. The next printing was the clearance test. And here the 0.4 mm clearance stayed on the plate. I could even release the 0.3 mm clearance. This is 0.3 mm. And I could break it out. This is 0.25, and this is welded together. Okay. The next printing was the M8 and M6 bolts printed in horizontal position. And this is the Vase mode printing. And this is for the layer adhesion. I will explain them later. And now it's time to replace the nozzle, and I will show it only once in details. In the next step I'm taking off the silicone cover, and I'm careful with these wires for the hotend and the thermistor. And then theoretically I should take off the fan shroud to access to the heat block with this open end wrench from one side, and from the other side to lose the nozzle. But I'll do it from the back side because I'll try to do it faster without removing the fan shroud. No, unfortunately this will not work. Instead of using the open end wrench on the heat break, I will try to use some bigger wrench to hold the block and try to remove the nozzle. 230 degrees preheating the nozzle. And I will clean with the brass brush the nozzle. I can see some burn material on it. I'm removing the filament from it. So push down a little bit and then pull it up. Lock the end of the filament. Don't forget the hotend is hot now, very hot. 20 mm open end wrench on the block. and put the nozzle on some plate or something that's not flammable. And let's inserting 0.3 mm nozzle. I will start with my hand, but I have to be fast because it will heat up very quickly. The correct and safe method would be to wait until the hot end cools down, insert the nozzle, then heat it up again, and then tight it finally. And now the tightening. And when you tie the nozzle, you should see some gap between the nozzle and the block of the hot end. That's normal, and in that case you did it correctly. The nozzle shouldn't align completely on the heat block. Let's see the Cura settings for the 50% size Benchy. So in prepare I can change the nozzle size to 0.3 millimeters, and I will change few things. So I always use the half of the layer height, half of the nozzle diameter, and the first layer I left it bigger. I will explain that later. And then I left the temperature to 210 degrees Celsius, and the retraction I reduced a little bit from 1 millimeter to 0.9 millimeters. And that's it. I can start with the printing. Now, after replacing the nozzle, you should re-level the bed, or if you have a BL touch, then set the new Z offset. But I like to do it during the first printing. During the skirt is printed, I set the correct Z offset until I get that first perfect first layer. This is faster method, but you need some basic experience with the 3D printing. It's almost finished. At the end I will compare them with the other small benches. This is with the 0.4 mm nozzle. Printed in 15 minutes. I will compare all printed parts somewhere at the end of this video. In the next clearance test I could release even 0.25 mm clearance. And again 0.4 mm stay on the bed. But 0.2 mm clearance was welded strongly in the place, and I couldn't release it with this Allen key. And next was again printing the M6 and the M8 bolts, and they are quite useful, you will see later. I could even place a nut on them without any clearing. And this is the badge. You can see here the first layer, and this is the printed version, and I will compare them at the end of this video. But this one looks really great, both sizes. And it's time to replace the nozzle, but now I'll not show it so detailedly. And next is 0.2 mm nozzle. And these are Cura settings for 0.2 mm in diameter. I am changing the nozzle diameter. And a few things I will change here. The layer height, of course, to 0.1 mm, and the first layer I will left to 0.15 mm for easier starting of the printing. And just one more thing I changed here is actually I reduced the retraction to 0.8 mm. And with the 0.2 mm I started again with the 50% Benchy, and it came out perfectly. But I will compare them at the end of this video. I will just mark it. And I printed the clearance test, and it was very similar with the previous 0.3 mm. I could release 3 circles here down to 0.25 mm. Jumps over. Okay. The next one was the M6 and M8 bolts, which I could use straight from the printer. because I could place the nut on them. And yes, visually also they look great. The next one was the badge. I'm marking it here, and actually the both size looks great here. And I had to try it, so this is 15% Benchy in the size. 50% Benchy. Full size Benchy. The next small thing I try to print is the gear of modulus of 0.5. With 0.4mm nozzle I can print only down to modulus of 1, and this one came out perfectly, and it can work together with the injection molded version. And it's time to move up. So this is 0.6mm nozzle. After some practicing, I can replace the nozzle in approximately 3 minutes. And it is ready for printing in less than 3 minutes. Let's see the Cura settings for 0.6mm nozzle. So first I'm changing the diameter in the Cura. The next is to set the correct layer height. Usually half of the diameter, so this means 0.3 for the layer and also for the first layer in this case. I didn't change the temperature yet, but I will do it later with bigger nozzles. And one more thing, I have to raise the retraction in this case. That's important. And again, I'm starting with the printing, and I'm changing the Z offset during the live printing until I print the skirt. Printed in 1 hour and 7 minutes. I will compare the Benchy printing times later in this video. Next printing was half-size Benchy, which didn't come out nicely. 18 minutes. The chimney is quite ugly, but I will analyze it later compared to the others. Starting with losing the details. Next printing was the clearance test, but you will see I couldn't release not even one cylinder. So the 0.4mm was the biggest, but that was welded too. The accuracy of the clearance is so bad that I couldn't even force normally the full size Allen key. So I printed a smaller one, but no, I couldn't release not even the 0.4mm. I mean, I can see some gaps, but it is welded together, so I couldn't free it. The next printing was M6 and M8 bolts, but with this nozzle diameter this was quite useless printing, because those threads came out like cylinders almost. Definitely very ugly threads, and I have to clean them to be useful, but I will compare them later. It's time to move to 0.8mm nozzle. And now with some experience I can replace the nozzle in approximately 3 or 4 minutes. And again, the first printing was the Benchy, and I set the Z offset during the first printing. Now I raised the temperature by 5 degrees Celsius, so nozzle can melt the filament with this higher flow rate. But now I have a cooling problem. This fan shroud uses the stock fans, but the airflow is weaker. 46 minutes. I printed a half-size Benchy too, and I also noticed here a little bit more stringing. It looks like I should raise the retraction even more a little bit. And yes, definitely more cooling would help. Here you can see at the end of this Benchy. Printed in 15 minutes. And for reference, I printed that batch 2. This is the printing of the first layer. And I will compare all them together later at the end of this video. But definitely this nozzle size is too big for these details. And I was curious about the layer adhesion. So this is the 0.8mm nozzle and I have 2 walls. And I want to compare it with the 0.4mm nozzle with 4 walls to see is there any difference in the layer adhesion. And just for testing, this is the M6 M8 bolts, but you will see quite useless printing because those threads looks definitely almost like a cylinders. And it's time to test a 1mm nozzle. Now in Cura settings, I raised here the retraction to 2mm, which is quite big compared to 1mm, which I usually do. And yes, the temperature also raised here, but I expected a lot of problems because now the cooling will be even weaker here. And here you can see the first layer of the Benchy. Too big overhang for this layer height. And definitely the cooling was not enough for this big flow rate of the filament. You can see the bridging moment of the cabin. And this is the top of the Benchy, the chimney. And again, for the reference, I printed the batch 2, but this text is very hardly readable. And just for another comparison, this is printed in spiral vase mode. And later I will compare it with printing from the 0.4mm nozzle. And let's analyze the printings. So these are full-size benches from 0.4, 0.6, 0.8 and 1mm nozzle diameters. I mean, with the 0.4 you're probably familiar, it came out great. I don't like these seams are a little bit visible, but it's acceptable. This is the first bottom layer. 0.6 was very similar. I can see some problems with the melting here, so actually it would require a little bit more cooling, but the overhang came out great. Firstly, seems a little bit bigger on this one. 0.8mm seams are very noticeable, so I really don't like this part, but this is the issue of the slicer, not of the nozzle of the printer. Biggest difference actually you can see on this top surface because it has different layer heights, and this is the best and this is the worst. And actually with the what is this 1mm nozzle, it didn't even have enough time for cooling, so definitely even this overhang case a very big problem. So this definitely 1mm nozzle is not for printing benches. And now let's take a closer look of these 50% benches. This is the 0.8mm. This is the biggest nozzle I could still print, this 50% Benchy. This is 0.6mm nozzle. Well, quite exceptional, only on the chimney I didn't have enough time to cool down the layer. 0.4mm. 0.3. Very nice. And this one is with 0.2 millimeter nozzle, and it came out perfectly. Even the first layer, the hole, the bridging, the chimney. And just another quick comparison of the 50% Benchy. This is printed with 0.2 millimeter nozzle, and this with the Iligumaras with the resin printer, and the quality is very similar. So this is 50, this is 15. This was the smallest Benchy which I could print, and it still can be recognized. Even the small hole was printed successfully. For the most useful thing I could print with 0.2 millimeter nozzle is this gear of modulus of 0.5. If you're not familiar, different gears can be used together only if they have the same modulus. And most common gears in those different toys are these, exactly with 0.5 modulus. With 0.4 millimeter nozzle I couldn't print anything below modulus of 1. And as you can see, I have this different set of gears, but I always need one which I don't have in this set, and now I can actually design and print my own with my own hole or thickness and similar. And now about the clearance, so from 0.2 up to 0.6 millimeters I could print, and I couldn't print anything above this. And as you can see, what I expected, so with 0.2 and 0.3 millimeters, I could release from 0.4, 0.3 and 0.25 millimeter clearance. With 0.4 nozzle, only the smallest was the 0.3, and with 0.6 and above, I couldn't release anything, so they are just welded together. So definitely yes, smaller nozzles are more precise, even in dimensions and clearance, for example. And these are badges, which is the only object which was printed from 0.2 up to 1 millimeter nozzle. This may be useful if you want to print something like, I know, business card or something like that, because here we have the big difference in accuracy in X and Y direction. Extremely nice first layer on the 0.2 and 0.3 millimeter nozzle, but 0.4 is also acceptable, but here I'm starting to losing the details. And let's see the other side, because here I have some letters which stand out, my and the word fun, and tech is actually inside this badge. So these are the top layers, and you can see from 0.2 to 0.4 very nice results. 0.6 here I'm starting to losing some details, but 0.8 and 1 millimeter are completely useless. And these are those 3D printed bolts. I will start with the Vase. So these are with 0.8 millimeters, and I cannot even see the threads on it. It's completely cylindrical, so very similar is the 0.6. So here I lost all those details, especially with M6. So these I will not even try to test. With 0.4 I could get some useful threads. I already cleaned them, unfortunately, so I cannot show you how it looks like. But 0.2 and 0.3, actually they are usable as they are now. So definitely yes, 0.2, 0.3 millimeters, much more accurate dimensions. And these objects are printed in a Vase mode, this one with 0.4 and this one with 1 millimeter nozzle. This one had some hard time until it didn't start with the spiral Vase, but look the difference in strength. So this is 0.4 and this is 1 millimeter, and I couldn't even press it. And this is very useful, so if you want to have something in a Vase mode but you want it stronger, or maybe you can use it to print with some transparent filament, because in that case it is recommended to use the Vase mode, it will be more transparent. And it's time to test how strong are those printed threads. And I will not do the pulling test, because with that experiment usually it breaks on the cross section, but I want to see how strong are the threads. And usually with the torque test the threads are shared out, so Here I can know how really are strong those threads. For example, will this with 0.4 millimeter or maybe this with 0.2 millimeter nozzle is stronger. I have here M8 nut, and I will use this plate as a washer, and I will insert this bolt. And with this torque meter I can twist it and record the maximal torque, and I will do that with every bolt, and then I will know how strong are those threads. 2.0, 1.9, and as you can see the effect is very similar, so there is no big difference between two. So 0.2 millimeter thread is nicer and immediately usable after the printing, but the strength is very similar to 0.2 millimeter printing. Just quick check of the Vase. These are printed with 0.4 millimeter nozzle, 24 grams, and these are printed with 0.8 millimeter nozzle, 24 grams too. Printing with 0.8 mm nozzle was stronger, approximately 10%, and probably because of the bigger heat capacity and weaker cooling. Here you can see the Benchy printing times, with orange the full-size Benchy and with blue the half-size Benchy. And maybe an interesting information is that if I would print with 0.3 mm nozzle full-size Benchy, it will be printed in 3 hours and 26 minutes, and with 0.2 mm nozzle in 6 hours and 9 minutes. And now the conclusions was first about the material. I contacted MicroSwiss about the plated wear resistant nozzles. It has wear resistant, but they don't recommend to use them regularly with the carbon fiber filaments. For this they recommend to use or hardened or stainless steel nozzles, and I will test this with the carbon fiber filaments in maybe a month from now. About printing with the smaller diameter nozzles. Actually it is easier than I thought. With settings you cannot go wrong. Everything which works with 0.4 mm nozzle will work with 0.2 mm nozzle. Of course you have to change the nozzle diameter and set the layer height, but it will have enough time to melt the filament. The retraction also will be enough. You can even reduce with the 0.2 mm nozzle. Of course the printing is much slower, but you will get really nice details. You have to pay attention that you have to use some better quality filaments, or just use average, don't use some cheap filaments for this, because you need very constant material and constant diameter. And it is very useful if you have some precise direct drive extruder. The MicroSwiss which I used is the direct drive with gear pulleys, so it feeds the filament very accurately, and also the retraction is also very accurate. Also you have to pay attention that the level must be perfectly leveled. Okay, so with this the BL touch helps a lot to set the correct Z offset. Maybe it is easier in the settings if you set the first layer a little bit higher, so don't use 0.1 mm, maybe 0.15, and in that case it's easier to get that first layer. But usually with printing smaller parts you will not use the whole surface of the bed. Actually I found out for me that this small gear is very useful things. Maybe you can give me some tips why can I print with smaller diameter nozzle. I'm talking about functional parts, not figures or something like that. Now about printing with the bigger diameters. Well, with 0.8 or 1 mm nozzle I have a problem with the cooling. Here I have to raise the temperature so the hot end have time to melt this bigger flow rate of the filament. And I must have better cooling, but actually this fan shroud which I use is not good enough for this cooling, but because I'm using the stock fans. So if you want to go with 0.8 or 1 mm nozzles, definitely you should pay attention that you need something which has a bigger cooling. With the setting also you have to raise the retraction. What I couldn't solve the problem are these seams. And I noticed it's problem with the Cura. With the Prussian slicer I don't have these big Z offset seams. Maybe you can give me some suggestion how can I reduce these seams, because they are very visible. Actually, the 0.6 millimeter, it's also quite faster compared to 0.4 millimeters. I still get enough details, so definitely for some functional parts, I recommend to go with the 0.6 millimeter nozzles. You will print it faster and you will have very similar dimensions and accuracy. Okay, any suggestions from your side, please let me then in lines in the comment. Thank you for watching and happy printing!